Okay, for just a minute, let's forget all the hype about the next giant AI model. Today, we're doing something different. We're grabbing our digital pickaxes and we're heading back in time. Think of it like an archaeological dig, searching for forgotten solutions in the very bedrock of computing history, solutions that could be the key to a much more sustainable future. So let's get this expedition started.
So look at this. On the left, you've got the current state of AI. It's this colossal, power-hungry machine, just burning through megawatts of energy in this relentless race for more and more power. And on the right, it's like a whisper from the past, just a few lines of code from the 1960s. It's proof of a totally different philosophy, one built on elegance and efficiency. And that right there, that's the central conflict of our story, the clash between brute force and brilliant frugality. You know, we have this deep-seated belief that progress is a straight line. It's always moving forward, always getting bigger, always getting more complex. But today, we're going to challenge that idea. We're going to explore what happens if the key to solving some of AI's biggest problems isn't in the next big thing, but in a journey of rediscovery. To really get why this journey back in time is so critical, we first need to face the sheer scale of the problem we're up against today. And it's a big one. The hidden and, frankly, completely unsustainable cost of our endless demand for computing power.
This graph, well, it tells a pretty startling story. Just look at that curve go up. Early computing was lean because it had to be. But today, the energy cost to train just a single large AI model is absolutely astronomical. We're basically building our future on a foundation that's cracking under the weight of its own power demands. It's a real paradox of progress, isn't it?
And this quote just hits the nail on the head. We're operating under this really dangerous illusion that we have unlimited energy, unlimited processing power, unlimited data. And this myth, it's kind of made us intellectually lazy. We've started favoring brute force over truly elegant, efficient solutions.
So if the current path is basically a dead end, where do we find a new one? Well, the answer, maybe surprisingly, isn't in a server room at all. It's in a forest. We're going to use this incredible concept from biology to guide us.
So in nature, there are these things called mycorrhiza. They're these amazing fungal networks that connect the roots of trees underground. And they're not parasites. It's a totally symbiotic relationship. The fungi break down nutrients the trees can't get to, and in return, the trees give them sugars. This hidden network makes the whole forest stronger, more resilient, and way more efficient.
And that brings us to our map for this journey. I want you to think of modern AI as the forest. It's powerful, it's massive, but it's also incredibly hungry. And these ancient algorithms from the past, they are the fungal network. They're the hidden, efficient web that can nourish and totally supercharge our modern systems, creating a new kind of sustainable symbiosis.
All right, let's start the dig. We're traveling back to the 1960s, a time of unbelievable constraints, to unearth what I like to call digital fossils.
Just try to imagine coding on a machine with less memory than a single icon on your phone. I'm serious. That was the reality for the pioneers back in the 60s. But those extreme limitations, they weren't a problem, they were a catalyst. They forced a kind of algorithmic elegance that we've totally lost in our era of abundance. And the best part? Today, we can resurrect these hyper-efficient fossils and unleash them with modern computing power at scales their creators could only have dreamed of.
And this is a really crucial point. The code from this era wasn't just about getting a job done. No, it was an art form. Every single line was deliberate. It had the focused, powerful economy of movement you'd see in a martial art and the complex, beautiful, interlocking structure of a Baroque symphony. Every single operation mattered. There was no room for waste.
Let's look at a real example. So think about an old sorting algorithm that was designed for a machine with just a few kilobytes of memory. The challenge was immense, right? So instead of creating a new memory-hungry list, the algorithm used this incredibly clever logic to swap data points in place, like a perfectly choreographed dance happening in a tiny, tiny space. The result? Maximum output from the absolute minimum input. That's just pure elegance.
Okay, so we found these fossils, we've dusted them off. Now what happens when we bring this ancient wisdom into the 21st century? Well, the results are pretty staggering. And this right here shows the impact perfectly. Just look at the energy use of a standard AI server running some brute force task versus one using a rediscovered frugal algorithm. The difference isn't just a little bit better, it's a complete paradigm shift. This isn't just some academic thought experiment, this is a massive competitive advantage waiting to be claimed.
So the key takeaway here is that this kind of frugality goes way beyond just saving a few bucks on a server bill. For every single watt of power we don't use, for every computational cycle we manage to save, we are directly reducing our collective digital carbon footprint. Sobriety in our code is actually a powerful environmental tool.
And this isn't just theory. It's a call to action for developers out there. In finance, these algorithms can shave precious nanoseconds off of trading systems. In logistics, they can tackle insanely complex routing problems on a fraction of the hardware. And for the Internet of Things, this whole idea opens the door to running powerful AI on tiny, low-power devices that couldn't handle it before.
This table just lays it all out. The difference is stark. The brute force paradigm demands massive energy, massive hardware, and it often leads to bloated, complex code. Our digital mycorrhizae, this frugal approach, is the complete opposite. Super low energy, minimal hardware, and an elegant simplicity that's actually easier to maintain and to understand.
And this brings us to our final section. This whole journey into the past forces us to ask some really important questions about our future and about the legacy we're all creating right now.
Remember how we started by challenging that idea of linear progress? Well, maybe technology, just like the natural world, doesn't just march forward in a straight line. Maybe it moves in cycles. Ideas fall into decay, they get forgotten, only to be rediscovered and reborn when their time comes around again.
And that idea places a new kind of responsibility on all of us in the tech world. Our job isn't just to build and consume the next new thing. We actually have a duty to be archivists, to preserve and really understand our technical heritage, because the solutions to tomorrow's biggest problems might be just waiting in yesterday's code.
Which leaves us with one final thought to chew on. As we build our huge, power-hungry AI models and our incredibly complex software, we really have to ask ourselves, what are we leaving behind? Are we creating resilient, elegant systems? Or are our creations destined to become the bloated, inefficient fossils that the digital archaeologists of tomorrow will look back on and wonder, what on earth were they thinking?